Hey guys, Mr. Perez here with Module 5, Lesson 5, the area of polygons through composition and decomposition. I want to do a little bit of vocab work with you guys here. We see two words here, composition and decomposition. Now, the word composition means that when you put things together, when you compose something. So to compose means to put together. And then you have the word decomposition, decompose. So the word decompose means basically to take apart. So decompose means to take apart. As I write these down, you should be writing it down in your notes. Or hopefully you were able to print out these pages and you can write it in your pages right now. So composition means to put together and decomposition means to take apart. So we have opening exercise. We actually have two different problems here. I'm just going to go ahead and put a number next to them. We have number 1 and we have number 2. They are distinct different problems, but we're going to be using this same diagram over here in order to do each of these problems. After each problem, I'm going to erase my work. So what I would recommend to you guys is either use a pencil or to redraw the shape somewhere, maybe on a nice fresh sheet of paper. Hopefully you have an extra sheet of paper so that you can just redraw the drawing and then you could do both problems. At the very worst, you could at least do number 1 and skip number 2. So question number 1. AB equals 10 units, FE equals 8 units, AF equals 6 units, DE equals 7 units. Find the lengths of the other two sides. So what they mean by this, AB means the 2 points or the line that is formed when you connect points A and B. So if I search for A is right there, and I search for B, there's B. And then if I connect them, the line segment that connects these two, it tells me that it is 10 units. So I'm going to go ahead and label that. I was going to put the units there. I changed my mind, and I'm just going to label it with the number 10. And then the next section says the next piece of information, FE equals 8 units, right? So FE is this line segment that connects these 2 points, F and E. So I'm going to go ahead and label that as 8. Then we have AF equals 6. AF equals 6. That would be this line segment connects points A and F. It equals 6. And then they finally give me DE equals 7. DE equals 7. So there's D, E's already marked, there it is, and then I'm just going to connect those, and that is going to be a length of 7. All right, now how do we find the other missing shapes or the other missing sides? So we want to focus on getting the length of DC, and then also the length of BC. Right? So we want to find out what is the length of BC, and we want to find out what is the length of BC and DC. Right? So they don't really tell me that information, but I have to use my deduction skills, my detective skills, and I want to identify the fact that we know some information here. I know that if I have a point that goes all the way across this shape, it's going to be 10 units long. It's going to be 10 units long. So therefore, I know that the length from C all the way to this imaginary point right here, if I were to go across, that would actually equal 10. And what I do know is that from this point to this point is actually already 8. So let me go ahead and label that. So from here to here, it is 8 units long. So if I know the whole length is 10 and I know that section there is 8, the section that I care about, which is this point right here, DC, I know it must equal 2. Right? 8 plus 2 equals 10. I'm going to go ahead and erase this so that it's not cluttered. Hopefully you're using a pencil. So there we go. DC equals 2 units. So I'm going to go ahead and label that over here on the left. And then now I want to find BC. I'm going to use a similar strategy for figuring out the length of BC. Now BC is the whole length of the side. So, but I know that a portion of it from here to here is 6. So I know that from here to here, it's 6. And then I also know that from point E to point D, the rest of the way, you can see is 7. So I know that from this point in the middle to point C, it's going to be 7. When I put 7 and 6 together, 6 plus 7 equals 13. So the length of the entire side is 13. Therefore, the length of BC is 13 units. So it just takes a little bit of detective work. Yeah, you have to kind of look at the picture as a whole and kind of piece it together. And also just make really good judgment calls. So I know that the length of BC is going to be longer than the other sides across. So if the other side is 6 and the other side is 7, I know that BC, the length that I figured out over here, must be bigger. So, and how much bigger? Well, exactly 7 plus 6, which is 13. Same thing when I was finding out this guy right here, I knew it had to be smaller. So I just had to use my information from the rest of the sides in order to deduce that that would be 2. All right, let me go ahead and erase this, and we get to the next question. So the next question is using the same, either redraw the shape or erase all your work, and you could go ahead and try number 2 along with me. In fact, go ahead and pause the video, work out number 2 on your own, see what you can do, and then come back here. Go ahead, pause the video now. All right, so I'm back here. I'm going to go ahead and use the information that they give me in order to identify the information I already know. DC equals 10. Okay. FE equals 30. FE equals 30. AF equals 28. AF equals 28. And BC equals 54. BC equals 54. They give me some different information, and they're forcing me to find out some different information. So here's what I do know. I do know that I need to find the length of AB, which goes all the way across. So I'm just going to add the other 2 sides that are going across. First of all, this length here, which is 30, and this length here, which is 10. To clarify that for you guys, from point A to this imaginary spot right above E, that would be 30. And then from that imaginary spot in the middle to point B, it's the same as it is across on DC, it is 10. Therefore, the length of AB equals 30 plus 10, 40 units. The length of DE, this is where subtraction comes into play, because I know the length of BC, the whole length of the shape is 54. And I know that this section already is 28. So going across, I know that this section here is 28. So I need to find out 28 plus, what is this mystery, equals 54. So I could always do some subtraction. 54 minus 28 will give me my answer. Let's see, 28 counting up, 38, 48, would be 26. 26 units. I just did subtraction in my head there. So I know instead of that question mark, I'm going to go ahead and clear that question mark, and I'm going to put 26. And I kind of got ahead of myself. Since that's 26, then I know that ED or DE going on the other side is the same length, which is 26. Right? So you're going to see problems like this, random shapes, and it's going to be your job to figure out a lot of key information about it. There's going to be some parts that are missing, but if you could do a little bit of detective work, you're always going to be able to find the length of the sides. Additionally, you are going to see problems where they ask you to find the area of these mystery shapes. And one of the big key things you're going to have to do is just really break it apart into sections. So I don't know how to find the area of this upside down L shape or 7 shape. but I do know how to find the area of this rectangle plus this rectangle. So if I find the area of the top section and then the area of the bottom section and add them together, I have now found the area of the entire thing. So, yeah, moving on. And here's where we're actually going to do this. This discussion is really about that idea. There's two ways that we can find the area of this kind of U, kind of fat bottom U shape. So the first way I want to do it is, let's just imagine that this is an entire rectangle. I'm going to close it up. I'm going to ignore that like box in the middle. I don't really care about all this. I'm going to ignore that for now. So I just added space. I added all of this space to my shape to make it a complete rectangle. So the fact that I added the space, it means that at first I'm going to count it as my area, but then I need to get rid of it. So here's what I mean. First step, I'm going to find the area of this entire rectangle and all the space inside. The entire rectangle, this entire rectangle, and in order to do that, I need to know what is the base and what is the height. So the area of the entire rectangle equals base times height, 7 times 9, which equals 63. 63 meters squared. That's the area of the entire rectangle. But remember, I need to get rid of this space inside. It shouldn't count. This space inside, I need to remove it from the area I just calculated. I need to cut out this blue square. How do I cut out the blue square? Let's find the area of that blue square, and then let's subtract it from our original. So the area of the blue square is, well, the base we have to figure out. Check this out. We have 7 on the bottom. So I know that this entire side totals 7. Right? We have a 2 right here. We have a 2 right here. What must the missing middle section be? 2 plus 2 is 4. 4 plus blank equals 7. So it obviously is going to be 3. Right? That whole side adds up to 7. So now on this triangle, on the blue triangle, the area is going to be base of 3, height of 4, which equals 12 meters squared. So remember, 63 represents the area of the entire rectangle. The entire rectangle. Right? All of this. But then I'm going to subtract this section here if I'm going to subtract 12. So I end up getting 63 minus 12. The answer is actually going to be 51 meters squared. 51 meters squared is the area of the actual shape that I'm concerned about, which is like the fat U shape. So I did this problem by using a composition. I built it up. I'm going to go back up top where I said I put together a shape. So I put it together by adding on and then using a little bit of subtraction, number manipulation. The other method is I'm going to decompose the shape. I'm going to create 3 separate rectangles. Now, in order to get the area of each of these rectangles, so let's call it the blue rectangle, let's call it the red rectangle, and then we'll call it the purple rectangle. So I need to find the area of each of these 3 rectangles separately, and then I'm going to add them together. Right? Starting with the purple rectangle. Area equals base times height. 7 multiplied by, okay, well, what's the height? What's the height? The entire length of the shape is 9. And I know that this top section here is 4. So I know this section is 4. That means this bottom section must be 5 because it must add up to 9. Right? So my purple box has a base of 7 and a height of 5, which is 35 units squared. Right? Go into the red. The red has a base of 2. The base, I could flip it upside down. The base is on top. That's okay. and then the height is 4. So 2 times 4, that would be 8. And then for the blue one, it's the same. It's really the same exact. It's 2 times 4, which equals 8. Now, if I add these three numbers together, then I get the same exact answer as before. 8 plus 5 is 13. 13 plus 8 is 21. And then 2 plus 3 is 5. I get the same answer. I did the problem in two separate ways. On the left over here, I did a composition. I created an entire rectangle, and then I subtracted a piece out of it. And then over here, I did a decomposition, meaning I broke it up into 3 shapes that I could handle, and then I added them together. As you can see, same answer in both problems. Moving forward. All right, example 1, decomposing polygons into rectangles. The intermediate school is producing a play that needs a special stage built. A diagram of the stage is shown below. It's not drawn to scale, right? Let's take a look at the stage. So we have 3 very similar shapes, similar to what we just worked on in the previous problem. All right, question A. On the first diagram, divide the stage into 3 rectangles using 2 horizontal lines. Horizontal, remember horizontal means left and right, so horizontal. So I'm going to use 2 horizontal lines. Here is my first design. 3 rectangles. Guess what? I already did this problem. I did it right here on the right-hand side. It's the same exact problem. So I'm going to go ahead and label. I know this already is 35. I know this is 8. And I know this is 8. Great. Done all together. That adds up to 51 meters squared. I already did that. No reason to do it again. Second one, B. On the second diagram, divide the stage into 3 triangles using 2 vertical lines. Vertical lines. So what I want you to do is go to B, and I want you to draw 2 vertical lines that would create 3 rectangles. And then take on the challenge of trying to find the area of each of those rectangles. Go ahead, pause the video now. All right, back at it. So I'm going to draw my vertical lines. So I know that if I connect this down, it creates a long, thin rectangle on the right. And then this one going down, it creates actually the kind of fatter rectangle in the middle, and then the other long, thin one on the right. So if you couldn't figure that out on your own, well, I'm going to go ahead and ask you to pause the video again. Based on the information I gave you, try to find the area of each of those 3 rectangles. Pause the video now. All right, so I'm back. First of all, I'm going to find the area on the left, and I see that I have a 9 multiplied by a 2. This section is going to be 18. This section's also going to be 18 because it's the same as the other one. And then this middle section, well, I see that the entire length is 9. And I only need basically from here to here. Basically, I only need from here to here. So if I know that this section here is 4, if this is 4, I know the bottom must be 5. So I know that this is going to be a 5. And let me actually write that on the outside. So if this is a 5, 7 times 5, this is 35. Right? And actually, I gotta catch myself here because it's not 35. What did I do wrong? Let's see if you guys can figure out what I did wrong. All right, so what I did here is I actually used the 7, I multiplied it by 5. And I know that's wrong. That is wrong. It's not 7 because the whole length is not 7. I know that this little section here is a 2 based on the top up here. I know that this little section is a 2 based on the top. Therefore, if the entire bottom adds up to 7, then this must be a 3. Altogether, it's 7, but it's a 3. That means 3 times 5, this section is actually 15. And once again, it would add up to 51 meters squared. Question C on the third diagram. Divide the stage into 3 rectangles using 1 horizontal and 1 vertical line. So go ahead, pause the video, see if you can work this one out. 1 horizontal line, 1 vertical line. All right, so as you see, I already drew the 2 lines. I have a horizontal line and a vertical line. You could have also reversed that and did them kind of in the reverse order, but essentially you're going to get the same type of answer. So over here, well, I already know that this is 9 times 2 on the right. That's 18. So only these are going to be different. If I know this is 2 and this is 2, and this length, according to the opposite side over here, is a 4. So that's 8. And then this kind of square looking shape, I know it's not a square. Now, same as last time, I know that this top section is 4 from here to here. It's 4. That means this section here must be 5, just like last time. And then I know on the bottom, if this section is 2 based on the top, then I know that this section here must be a 5. That means it is a square, and it adds up to 25. 25 plus 18 is 43. 43 plus 8 is 51 square meters. So you can see I did this in 3 different ways, each of them using decomposition. I focused on finding shapes that I know. I know rectangles. Moving on. All right, question D. Think of this as a large rectangle. Actually, I'm not going to get into this one because I want you guys to remember what we did on that first problem. As you see it on my screen right now, this is not the work, but if you reverse back to when I did actually question number, not question 1, but I did this stage right here, then you're going to see the exact method that they want you to do here. So I'm just going to go through this quickly. What are the dimensions of the large rectangle and the small rectangle? Well, the large rectangle is 63. The small rectangle is 12. Go back in the video if you want to see further details. So the large equals 63 and the small equals 12. What are the areas of the 2 rectangles? Question 1 was asking about the dimensions, but the areas are 63 and 12. Question 3, what operation is needed? Subtraction. All right, let me go ahead to avoid confusion. And I kind of skipped number 1. Number 4, what is the difference in area? Difference in area is subtraction. 63 minus 12 equals 51. We already knew that. So what do you notice about your answers from all 4 of these? They're all the same. They're all the same. 51, 51, 51, 51. Doesn't matter how we did it, we always got 51 because it is the same exact shape. Right? It's that kind of fat bottom U shape. All right, so let me take a preview of what's coming up. Don't want this video to get too long. Example 2, decomposing polygons into rectangles and triangles. Parallelogram. ABCD is part of a large solar power collector. The base measures 6 meters, and we can see it labeled here. And the height is 4. We can see it labeled outside. Draw a diagonal from A to C. Okay, I'm going to go ahead and draw from here all the way to here. From A to C. Okay, what's the next direction? Find the area of both triangles ABC and ACD. All right, triangle ABC. Triangle ABC is actually this one. So it's from A to, actually I should have gone to B. Let me show that better. A connecting to B, and then connecting to C, and then we close it. So that is triangle ABC, and I'm going to find the area of the yellow triangle. Area of the yellow triangle. Well, in order to find the area of a triangle, we need to know its base and its height. So area equals triangle ABC. Area equals base is 6, height is 4, and then divide it by 2, and we get 12. Right? And then to find the area of triangle ACD, that's the top section, I know it's going to be identical. I kind of already know, but I am going to write this down. ACD, area equals, it still has a base of 6. It still has a height of 4. We're still going to divide by 2. The answer is still 12, and it's actually 12 meters squared. Question B, draw on the other diagonal from B to D, and then they want us to find the area of all of those. So B to D, or D to B. Find the area of both triangles ABD and BCD. So now they want me to find the area of, let me erase this, get this out of the way. They want me to find the area of ABD, which is this guy right here. Right? They want me to find the area of that and then also the top section. I'm not going to waste the time. What's the base of this pink triangle? What's the height of this pink triangle? Same thing for the top one. What's the base? 6. What's the height? 4. So that means 6 times 4 divided by 2. I already did that a number of times. The answer is 12 meters squared for both. All right, next problem. Example 3, now we have a trapezoid. The trapezoid is this kind of funky shape. It's still 4 sides. It's a quadrilateral because it has 4 sides. But as you can see, the top and the bottom, the top is 4 and the bottom is 8. They're actually different sizes now. So this is kind of a new one for us. We're imagining that this is a garden plot. Find the area of both triangles ABC and ACD. Then find the area of the trapezoid. All right, this takes a little bit of fancy work. So I'm going to connect A to C, and I'm only going to focus on this pink section right now. Only going to focus on this pink section. I want to find the area of this triangle ABC. The area of triangle ABC, I need to know its base. I need to know its height. And then I divide by 2. 40 divided by 2, 20 meters squared. Right? Now I want to find the area of the triangle ADC. Triangle ADC. So I want you to notice that, let me go ahead and do this one thing first. All right, so I'm going to actually flip this around so you guys can see. I didn't want the highlight to come. So I'll erase that. So putting this back in there so we can see what happened here. This triangle, now this bottom section right here used to be this section right here. So that's 4. The height, notice the height is, and actually, let me erase that. That's not what I was going for. The height is thinking upside down, going from there straight down. And it matches this. It's 5. So this is what I just did, just in reverse. Going straight down. That means this is 5. So that means I know the base and the height of this triangle. Right? So this is triangle ACD. And the area is base times height divided by 2, which is 10 meters squared. So find the area of both triangles ABD, and I'm not going to do that. They want me to reverse it. I already did it one way. I found the area of this bottom half, and I got 20. And then I found the area of this top half, and I got 10. So what is the area of all of it put together? 20 plus 10. 30 meters squared. Right, I'm kind of ignoring the rest of these directions, but hey, there we go. We found the area of a trapezoid by splitting it up, by decomposing into two triangles. I guess that is it. I do want to focus on one more trapezoid problem with you guys. Let's see if I can find a good one here. Number 4. Number 3. Let's go ahead and do number 3. Determine the area of the trapezoid below. So in order to find the area of this trapezoid, I'm going to split it up into two triangles. The first triangle is this kind of thin one. I drew a diagonal. And I need to know its base. And I need to know its height. The height is 18 as we see across. The height is 18. So for the pink triangle, the area is base times height divided by 2. That is 27. 27 meters squared. Now if I want to find the area of the purple triangle, the purple triangle is this guy. Right? Purple triangle. If I were to flip that upside down, I'm not, but if I were to imagine it flipped, its base would be 22. Its height would be also 18, and I'm still going to divide it by 2. So that would end up being, let me see, 22 times, I need a calculator for this one. So 22 times 18 divided by 2, and I get an answer of 198 meters squared. Now, if I want to find the area of them put together, I'm going to do a simple addition problem. 198 plus 27, and the answer is 225 meters squared. All right, this was a difficult lesson, so definitely make sure you're watching those lesson videos. The lesson video is of me working out all of these different problems. Another recommendation is to maybe get a little bit of a boost by watching that exit ticket video early. Maybe do it before you even try the exit ticket. Normally, I encourage you to try it first and then go to the video. But maybe watch the video first because this is a hard lesson. I admit it. I know you guys are going to have some struggles with this. Please embrace the struggle and know that it's part of the learning process. So I'm going to go off to work on the exit ticket video now. So I'll be there soon.